Yeah, it's a little muffled, but all right. Yeah, so hello everyone. Like I said, I'm Elijah Simmons. Today I'm going to talk about Zerosync. It's a new sync engine for the web built by Rossi Corp. And so to get right in, I'm going to kind of introduce myself a second time. Just to reiterate, I've been programming for the last 2 years. Started when I came to Messiah University. I'm currently pursuing a computer science degree, and I'm a junior, so I'll graduate in just over a year. And I've been working with Jesse at OE and IntelliSuite for the last 8 months, and it's been a fantastic time. I've learned a lot. So we'll get right into Zero. And to start off, I want to talk about your standard SPA application or your standard React app. Basically, what everyone's using nowadays to build the websites that we all see and we all love. These are all built using your app, and then you've got your API server in between the app and your database. And then you'll make REST API calls between the server to access the database, and then the database will return whatever result that it gets. So this is how we've been building apps for the last, 20 years, maybe more. I haven't been alive more than 20 years, so I'm not quite sure, but we've been doing it like this for a long, long time. And there are some inherent difficulties in this this organization of the apps, especially when it comes to things like React or Vue or some of the modern frameworks that are really hot and everyone's using nowadays. And the big problems are loading. So I took a screenshot from one of my very first React project. Mike might remember this. We were building a social media project for college students to be able to interact on campus, and we were trying to get cross campus, but it was our very first React app. So we didn't architect it very well, and we had to write a whole bunch of code just to load our users onto the pages for displaying them. And we ran into like a lot of problems when one of the profiles was updated. So you have an update that gets sent to the database, and if you're not careful, you've got to fetch all the users again, which is what we're doing here. And the really hard thing is forcing the page to refetch that data. You've got to do something like a use effect, or like right here, we're using a use ref and a use effect. To reiterate, we were building our first React app. It was the social media project. And we wrote this 30 some odd lines just to manually reload our users when we had a change in the state of one of the profiles. So incredibly non-performant. You should never code like this, like ever. This is our first project. But this is not too uncommon in React apps and modern apps. You have to do a lot of tricks to get around reloading stuff, and just in general when you're initially doing that load. So like I said, the refetch on each update was our first problem that we had, and we solved that using a use effect and a user ref, but this was not very performant, and we were making our users wait for changes. So we'd have to display either a loading or the page would flicker whenever we had these updates come back from the database. And it wasn't a great user experience, and clearly it wasn't a very good developer experience. And of course, Firebase was charging me for a read each time that we had to read the database. So that adds up on your credit card eventually, although I don't think we ever reached enough users for that to be a problem. But yeah, it's very hard to get performant, developer-friendly, and user-friendly apps nowadays with all the different tricks you have to jump through to do them. So one of the tricks that React came up with, and TanStack Queries 1.2, and a lot of other frameworks have them too, is optimistic updates. And what these are supposed to do are allow you to modify the client state while the HTTP request is in process. And then assuming the HTTP request was successful, everything's okay. But otherwise, we're going to have to roll back the client, and we're kind of stuck showing the user something that hasn't actually happened, or not showing the user anything at all. So really some difficult problems, and even all these solutions like use optimistic updates and everything, they don't quite solve this problem. But that's where the big idea behind Zerosync came in. Is Aaron Boudman said, "Can we just preload everything?" This is the heart behind Zerosync and the heart behind Rossi Corp, and it's very common for the best technologies that we have today to be built on a simple statement like this. I think the simple statement for Git, the version control software, is, can we just copy everything? So the idea for sync engines, and Zerosync specifically, is, can we just preload everything so that when we need to either read the data or make a change in the data, it's right on the client. So there's no wait time. It's all reactive, just like React is itself, but for your queries and for your database calls. It's a completely new way of thinking about the modern app and how it's built. So to get into some of the technical details of how this works, well, I guess I've got the history of sync. You can see here it started back in like the 1990s, and then Google Docs was actually something Aaron Boudman was a part of developing, and Figma, I'm sure a lot of you are also familiar with, and it's been around since 30 years ago. It's just we haven't used it in the web apps yet. But anyway, getting into the details behind it. So just like our normal app, we've got our app, but our app has a sync client, and the sync client is syncing with a sync engine. The sync engine, this is really the heart of Zerosync. This is what they've developed to be the middleman between your app and the database. And the sync engine does an incredible amount of things, but it does two things specifically. Number one, it's gonna interact with this client that's inside your app via WebSockets. So it's going to update your app when your app requests some data, or take a write from your app when your app writes, and it's going to do that through the WebSocket. So your request time is almost null, right? It's extremely fast. And then in terms of the database side, your sync engine is going to be watching the replication log of your database. So right now they only have support for PostgreSQL. They're working on support for MySQL and I think Mongo, although I'm not sure about that one. But the idea is your sync engine is subscribing to the replication log of your database. So every time that your database has a change in it, whether it's from another user, it's from the user that's the client here, or if it's just an asynchronous change, your sync engine knows about it immediately because it's subscribed to that log. And because of the WebSocket, your sync engine's able to get this change to your client immediately. To look a little deeper into this, I've got a map from their website, their docs. So they have support for React and Solid.js right now. And like I said, you have your Zero client in there. We'll look specifically at the code of this in a little bit too, as I show you an app that I built. But the WebSocket, that's your connection to your Zero cache. Your Zero cache keeps the data that you need in a SQLite database, and it also sends the data to your client's IndexedDB. You can use a couple different stores, but the most common one is IndexedDB. And so that puts all the data that you need, not everything from your database. We'll get to that in a second. But that puts the data that you need directly on your client. So everything that you've preloaded into your IndexedDB is immediately available for your app to use. And then from there, your Zero cache is just interacting with your database via like normal queries and changes, and then of course subscribing to the replication log of that. The very neat thing about the way they've built the zero cache, and this is probably the most impressive thing about it, is the fact that it only preloads the data that your app is going to be using at that time. What that really looks like in the code is basically the data that I choose to use in my app will be preloaded on render. But if I didn't call that data anywhere in the app, or I'm not on, like, well, yeah, the size limit of the index DB is around 20 megabytes, so it's pretty hard to do more, but it's definitely possible. So for some reason, I've tried to preload more. It's actually going to preload only as much as it can, and only the stuff that you need immediately. So pretty cool feature there. And here's what it looks like in some of the code. This is from one of their GitHub repo examples. It's one of their latest ones. They were able to create an app that has over 100,000 records of different playlists and songs. And what you see here in the use query hook, this is React, is what they call ZQuil. So it's SQL, but with a Z. It's their database language for using their cache server. And this is pulling a playlist of all the related tracks, albums, artists, ordering it by and where. Looks like normal SQL almost, or it looks like Prisma. But this is reactive. So it's a hook. It returns immediately from the index DB, the data that's there. And then it's immediately rendered in the DOM. And when you want to make changes to this playlist, like star is their example here, if you want to favorite a track, you just call the mutate function on the Zero client, and then you will update that record, and the change will be reflected immediately because it sends out two requests when you call an update or you call an insert. It sends the data immediately to your IndexedDB and your cache server. So that change reflects immediately. It also sends to your database, and then that will return again to update, because there are certain cases where an update could fail on the database but not fail on zero cache. And that's obviously one of the big concerns that they're working to overcome. So you can see a flicker if that's possible, but I'll show you why it's not really possible, and it's because of the way they've architected this cache server. But that's what the code will look like, and you can already see how much cleaner this is than what Mike and I were trying to do 2 years ago on our own. Instead of having 35 lines of code to manage a loading state, we have about 3. We're just getting the playlists, and if they're not there, we'll return nothing. If they are there, we'll render all of them. Really simple, and I'll show you what it would look like for our app if we converted it to Zerosync. So rather than 30 some odd lines and using ref and using effect, we would just have 2 lines. That would be our display users and all users. And really, you could bring this down even further if you wanted more performance to just splice all users to get your display users, and you could only have one query. So quite an improvement on this app here. Of course, it wasn't beautifully architected before, but you start to see how much simpler it is to implement a very complex problem that we have in our modern apps. I want to switch gears a little bit before I show off the app I've built and kind of explain the problem that this app solves and why Zerosync is so good at it, and why it's fun for me personally. So I'm quite an avid chess player. I've played over 37,000 games on my main account. It says I've spent 87 days on the website. So played quite many games of chess, competed in many tournaments. And if you or any of you have ever played online chess, there's this this chess problem online where you have cheaters and you have lagging. And I'm going to talk about how Zerosync solves the lagging part of it. Interestingly enough, I found this like 12-page article on the chess problem. It was all like math and code. It was really, really high level. I didn't understand most of it by the time I got to the end. But this shows you how long this problem's been around. And there have been different solutions today in modern chess apps. But I think Zerosync can do even better than these. And I'll explain why. So kind of going back to what we've been talking about, there's this problem of waiting in apps. What do we show the user while we're waiting? And how do we manage the state when we're waiting? And this has really big significance in games like chess or other online games where you've got timers. So we make a move on our chessboard. We wait for the write to the database. Then our opponent is going to have to wait for the reply. In the time that it takes for our HTTP request to get to the database, and then HTTP request, you'd have to subscribe to it or something to update our opponent's board. That's always going to be like at least a second or two. It's been in the early days, I was reading through the article, it said 5 to 10 seconds. Very unplayable at low time controls. And I'm definitely a low time control person, so I hate the lag, and it still exists in modern apps. And then you'd move again, but either your clock has been deducted more than the time you took to make the move, or your opponent's clock has been deducted because that time goes somewhere. So this is like a very fascinating problem, and it's not something that has been easy to solve. And the idea they came up with was time stamping. So in the early 2000s, they decided, hey, when I make a move on my chessboard, I will timestamp that move. And by the time it gets to the server, I'll check the timestamp between the time now and compare the two. The problem with this is that it's easily hackable, and lots of people hacked it, and basically nobody wanted to play the game. So a couple different websites actually went down because of this, and finally, they started using WebSockets in the late 2000s, but they don't compare to the simplicity of Zerosync. So I want to show off the app I built, and we'll look at some of the code and how Zerosync looks inside of a React app. So this is a React app built with Vite and TypeScript. Talking about our Zero client, we remember that sits on our client's app. That's right here in main. You can see here, we're creating the client here, and then we'll pass it to our context provider to give it to the whole app. So our whole app's going to have access to this Zero client and be able to make queries, mutations, updates, you name it. The very cool thing about the Zero client, in TypeScript especially, is that it's fully typed. So you can see here I've got this schema, line 20. If I hover over the client, I have all of my tables, columns, the types, whether or not they're required. My database is fully typed for me in the client, in the code too. So not only does this catch errors extremely fast in development, it also catches them in production. So once again, a focus on developer experience and user experience. We give the developer the tools to code really fast, and we give the user instant updates on their browser. You can see here we've got IDB, that stands for IndexedDB. That's where we're using to store the data we get from the cache server. Using this on a page, I'll show you the app, and then we'll kind of look at how the app works. So this is the chess, bullet chess. It doesn't have any fancy features yet, but it will eventually, and I'd like to make it public when I have a little more experience and more time on my hands. But let's create a new game. Let's search for the game. I'll open an incognito window to show how fast the WebSockets are. You can see how fast the moves update on both browsers. Oh, that's right. It doesn't like me doing this. Oh, there we go. Okay. Yeah, it's a little cut off, but that's all right. Let's put this game in the incognito tab. Can everyone see that okay?
Yeah.
Okay, good. So let's say this is the browser that I was initializing the game on. So let's say I make a move. I'm playing against AI. If I make a move, you notice how fast not only do the timers sync perfectly, which is through the database. I mean, a timer is a whole nother problem if you're ever looking to create a game online. Timers are no fun. But this one updates instantly. Nothing special on my end. I didn't have to do anything fancy, and I don't think I could have. But yeah, timers are updating instantly. Moves are displayed instantly. Talk about zero lag and just a perfect experience. This thing just makes random moves, so I can probably win pretty fast. But I'll show you the code while it plays itself. Yeah, if we look at our matching page where we first searched for a game, I don't really have a searching algorithm yet. There's nobody else online. It's just my machine, so I didn't make that yet. But here's what it looks like to create a game inside my database using Zero. I call Zero mutate. This is the name of the table. And then I just insert the values that I want. And like I was saying before, this is why it's really, really hard to make a call to your database that will fail on the database but succeed on the cache server. If I try to just mess this up and put in a value that doesn't exist, like fake, it's going to fail just rendering because fake does not exist on my database schema. And that leads to the kind of the next question is, oh, is my Zero schema always in perfect sync with my Postgres database schema? Yes, it has to be. They make that a requirement. If they aren't perfectly in sync, you'll get errors and that won't run. So that can be a little annoying, updating files over and over again if you're changing your schema a lot. But it'll always save you from a ton of errors that you didn't know existed, or just in development in general. So that's what I was talking about before. But you can see here, we're just inserting a game ID, our username, the opponent is just AI, and then this is our database. And then we navigate over to the game. If we look at the games page, pretty simple. I do have one use effect, so it doesn't completely eliminate use effects yet, but you can do it without it. I just use this to manage the state of the chess game and the FEN a little bit easier. And this would be our query. So rather than calling an HTTP request and waiting for this result, I'm just calling the hook use query. I'm asking for one game where my parameter in the URL, the game ID matches. So always going to be correct because we navigate straight from the matching page with the ID we just created. But this will give me my database game fully typed. And if it doesn't exist, it'll be undefined. I'll take that database game and I'll bring it down to my DOM here. And you can see I'm using it in these timers. In-game profiles is a timer. And I'm saying, oh, here's the current time, here's the player name, and here's the game. And that takes care of the entire chess game. Pretty incredible. I've tried to make chess games first when I started out in Scratch. That didn't happen. I tried to make one in Visual Basic with my class. That did happen. Once again, thanks to Mike and a few other developers, we were able to get that to work. But creating an online one, I've always wanted to do. And the ease with which I was able to make one here is just incredible. Like, yes, the chessboard NPM package was very helpful too, because it just gives you a chessboard with like all the moves, and it doesn't let you make illegal moves. So all that was solved for me already. But the interactions in the game being zero lag, I don't imagine it's easily hackable, although I'm sure you can use Stockfish probably. All that for just a couple lines that didn't really take a lot to understand. It's incredible, and I'm really excited to take this app to the next level and publish it. So yeah, that's how you will use Zero in your apps. And you can see here when I'm ending the game, I'm just updating the ID and setting it to inactive, and that boots you out. So let's see, is my timer still running? No, it already booted me out. But yeah, that's about all I had for the overview on Zerosync. If anyone has any questions now, I'll take some questions.
So one question I had is, if everything is in IndexedDB, why can't I go into like IndexedDB and like change it and like make that chess game like, totally in my favor or something like that, like change around the pieces or whatever?
Yeah. Well, Zero does have permissions. So I think that it's possible to set those permissions in a way that doesn't allow you to do that. I haven't played around with injections through IndexedDB like that, though. And I don't think that just changing the IndexedDB is enough to call a write to the database. But I could be wrong on that. I'm not sure.
What happens when you're over 20 megabytes?
It slows down, and it takes minutes to preload, and you don't get it all anyway.
What about slow internet connections?
Oh yeah, I forgot that. Not a good presentation. No. Yeah. So Zero actually supports offline reads and writes, assuming you've got the data in your IndexedDB. So even if the connection to the cache server is lost, and you make some changes, it'll actually update the database when you come back online, assuming it's not been more than 5 minutes, is what their docs say. But I've witnessed it 10 minutes updating still.
Does it just automatically handle conflicts then?
Yes. It uses the latest change, except when there is a delete. If there's a delete, it's gone. Nobody can bring it back. Any other questions?
What's your chess rank? Did you hear that, Elijah?
I did not.
Oh, sorry. What's your chess rank?
I'm 2000 USCF.
Dang, is that good? 10 times better than me. So okay.
Yeah, I did used to be in the top 100 for kids.
Wow.
Yeah. I'm much more rusty now. I couldn't do it.
They're negative. What did you say it's supported? React and what?
Solid JS.
Svelte. I know because the guy who, or one of the guys who does Syntax FM podcast, he actually made the Svelte.
Yep. There is community support for Svelte and Vue.
Okay.
Yep.
Angular. You guys speak up for a minute. What about Angular?
Angular? No support for that yet. You could make it though.
Oh, they want to do that.
don't worry, it'll make you develop some time really quick for that.
Yeah.